Get down to the B-side.
Okay guys, so now the pipe work's pretty much done. That's how it's sort of going to be the finished product. Finished doing the merge collector. Just tick with all the bits in here. That was an absolute pain in the butt, but it's come out alright so far. Just testing it and finalising what needs to be done with the port work, just to try and even the airflow out in between all the cylinders. So let's have a quick look and see where we're at, and then we'll go from there. We'll start adjusting a few things. Not too bad, pretty good. We can see these two are down. We don't need to add any more. Try and get some airflow in this one, that's fine. We'll just concentrate on these two and then we'll finalise on that one. So other than that, it's looking pretty good. So what I have noticed in the merge collector, try and get it to see, we can actually see these two runners here are the lowest ones. This one here and this one here. When you look at it straight on, we can actually see that the edge of the merge here and up here actually they're rounded in. So we'll try and add some weld along all the tops, on the tops around the sides here. Try and get some extra strength, and then we'll try and hammer a dolly out. Try and bring these out just so the air's evenly going into these ones. Get a bit more air into these ones, and that's the last runner there, which probably be able to get just by a little bit of grinding, so pretty good. Okay guys, so now we've finished off playing around with the merge collector, getting all the die grinding and that done, and I had to flare out a few of these edges. It was actually really handy doing the flaring on the flow bench. I could actually leave the flow bench running while you flare it, and you actually check the CFMs and see if you made a difference. If not, you continue on trying to flare it out a bit more, and basically sort of just work the merge collector so all the CFM would basically equalise and be all the same. So that was really handy. With one of the benefits with this style of flow bench, rather than testing individual runners, you just do it all on house and do it, yeah, all live sort of thing. So that was really handy. We'll do a quick test, show you what the results are, and then from there we can start making the basically the throttle body and the plenum to the merge collector. Looking pretty much all equal, everything looks good. Can't really ask for anything better than that. So from here on we can start making the throttle body and the little plenum to the merge collector. Other than that, it's actually turned out pretty good, and so far things are looking really good.
Hanging by a thread, hung up on all the words you said, breaking free from this conformity that you force on me. Everything I do is one big show. It's about damn time that I take control. Put me under a microscope and watch me take control. What's this? I finally read this helplessness. Tired of feeling like I'm upside down, so I'm gonna turn it all around. And and dear God, save my soul, 'cause it is flawed. Tired of feeling like I'm upside down, so I'm gonna turn it all around. Don't tell me that I need saving. Finally awake and living. Yeah. The pressure inside was building. I felt under attack, and now my mind's attacked, and I've chosen my path. I've chosen my path. What's this? I finally read this helplessness. Tired of feeling like I'm upside down, so I'm gonna turn it all around. And and dear God, save my soul, 'cause it is flawed. Tired of feeling like I'm upside down, so I'm gonna turn it all around.
Okay guys, so here it is. The manifold's pretty much in its finished form. We'll quickly do just a rundown of what the parts I've used and sort of why I've done this design, this setup, and we'll just talk about each part as we move down from the throttle body to the injectors. So we'll start off with the throttle body. The reason why it's such a big throttle body is to try and actually keep the air the same sort of size as the actual merge collector when all 4 ports come together. To try and give the best air distribution, and plus also try and keep the airspeed down to give it a better air distribution into the merge collector. As you can see, the merge collector, this is like my second project with aluminium, so it's still a bit average, but pretty damn happy with how it's come out. So with the merge collector, the idea sort of came with a turbo exhaust manifold, how all 4 runners come into the one before they go into the turbo, so that's where the idea initially came from. So I thought we'd try and reverse that idea, and hopefully, because now all the air is coming straight on, it's getting hard to open, as the air comes straight on now, that the air will have not much area to have to turn to get to another port. It's all in front of it. It only has to move a few degrees to the left or to the bottom or to the right, or vice versa. So it's all pretty much in front of it. Yeah, it really doesn't have to move around too much like in a big plenum chamber to get to the port where it's needed. Other thing that you can see at the top here is I put a little wall, had to build up a little wall because the ports themselves weren't quite centered to the actual throttle body, how the throttle body's straight. I can't really get a shot in the picture, it just doesn't really show up in the camera. But yeah, so the reason for that is to try and help air distribution at that top of the throttle body opening. Because one of the ports is off to the side, one of them wasn't actually getting any airflow at all, so I had to try and grab the air as it's coming through the top of the throttle body and yeah, try and get it to throw it over to the port where it wasn't getting much airflow. So that was the reason why it's got that big wall build up in there. The bottom ones are actually pretty well spot on, like, they're pretty good, so I didn't really worry about that. And plus I got a few other like air temp sensors, and I got a vacuum line fitting in there as well, so I can't do much with that. all the grindings. This is just one of those Chinese LS1 throttle bodies, 102mm. Actually, when they've done the machining, they actually have a humongous lump here. I'm not sure if that's actually what's supposed to be there. It looks like it was actually meant to be there, but I had to take all that out just to get a much better opening, just so there wasn't a restriction in the top half of the throttle body, and also to basically make sure that it definitely is 102mm all the way through. The reason why I stuck with this throttle body as well is because of the temperature, the throttle position sensor. That's pretty much the same as the other sensor that I was using on the other throttle body, so that's sort of why I kept with this throttle body. As you move down, the idea was just to try and get the bends. Each bend that I've used is 30 degrees. There's no other bends which are any more than that, so every single bend on the manifold is 30 degrees, just the intercooler pipe bend. So just to try and give it all the same, basically the same corners no matter what. So it's got like sort of the same radius all the way around, so just to try and give it as much airflow as I can. The actual runners themselves are 1/4 of an inch smaller than my other manifold. The manifold that I had, each port on that was 2.5 inches. That's huge. So I went down to 2.25 inches, which is pretty much the limit I could go down to without having to try and stretch these out too much to try and get to the 2-port opening on each of the runners on the head. So with dropping down with 1/4 inch in size, you've dropped a lot more area in the actual pipe itself, the inside there, and this will actually help increase airspeed. So hopefully at lower RPMs we get a little bit better airspeed, and that will help with the actual engine running, and maybe a little bit more power as well, just throughout the whole range of the RPM. So from there, you'll see injector position. This was the most crucial part, and I've really tried to spend a lot of time on the actual injectors themselves. I've actually done a injector sort of position changeover on the old manifold. Quick grab that now. Originally I had these injectors on a 45. Problem with that is, if you see in some of the photos that I got on my Facebook and that, a lot of the spray gets sprayed to the bottom of the port. Because it's on a 45, you're shooting the spray pretty much down the bottom of the port, and you're expecting the air to actually grab it and throw it to the back of the valve. At low airspeed, low RPMs and stuff like that, this becomes a problem with such big injectors. Also, the other thing you've got to remember too, if you plan on ever making your own injectors, your own manifold, is that with the sprays, they have like a 45-degree cone, so you actually have your injectors themselves. So yeah, quickly with the injectors, basically as you look at them, they have a spray coming 45 degrees out and also 45 degrees down. So if you go along and mount these on a 45-degree angle, the bottom of that spray is going straight to the bottom of the port, like straight 90 degrees. So, and then the other 45 degrees is going straight, which is where you want it. That's going straight across the top, running along the top of the runner. The other 50% of the spray, to me, so you got each side now, so we got sideways, so you got your top spray and you got your bottom spray, and you got your 2 side sprays. These are the most crucial things to me, because I got 2 of these side sprays which are going to be spraying straight parallel to the actual injector. So by having this on a 45 degree, we're still spraying this down to the bottom of the port, and we're still expecting the air to magically flow the fuel up, try and keep that atomized to the back of the valve. And this sort of doesn't really work too well. This wasn't working too well at all. We had real sloppy boost. The turbo was really doughy. It was really bad. The engine just didn't respond really well, and just overall the amount of difference from changing the injectors from a 45 degrees to basically a 20 degree, probably more like 25 degrees. now you can see the ejectors pretty much spraying straight along, and it sprays, majority of the fuel is actually more or less spraying 30 degrees to the actual port. So a lot more fuel was definitely getting sprayed and atomized a hell of a lot better. And with moving the injector further back from the head, this gives the fuel actually more time to atomize and to turn into a vapor. And to me, the actual gases of the petrol is really what's crucial and what mixes in with the air a lot better than what you will with fuel droplets. So I sat there and studied, and if you ever had a look at the Formula 1 engine dyno on YouTube there, you can just see that those guys have spent so much time with their injectors on just fine misting the fuel that it pretty much would just turn into a vapor by the time it gets into the actual motor itself. So this was something I was trying to look at and try and study what they were doing, and I'll try and replicate what I could do with what I had, what you can sort of get as a customer sort of product. So from there, the problem with this is now that the fuel still wants to spray to the bottom of the port no matter what, because it's still fighting with gravity, and the actual top of your spray now is going to come up and hit the top of the runner a lot more. So still 2 parts of the spray of the injector is basically hitting the walls and then dribbling down just into a full liquid, and then you got your middle of your sprays which would work really well. So the middle of the each side of the injector here would be working really well, and that made a humongous difference in turbo response. Boost control was just incredible, right? It's just a completely different motor, and it's just the most crucial part, and I think it's overlooked a fair bit on cars nowadays. So yeah, definitely if you get manifolds and stuff like that done, or you're going to make your own, little tip is to, if you haven't got a flow bench, you can't make a quick little home build sort of job, take it to a shop which has a flow bench for fuel injectors, and you can check out the spray on them and then measure the spray. And you basically want to get the spray as wide as the port, basically so the spray is touching just all the walls by the time it gets to the actual head. Then you know you've got the whole port completely covered with atomized fuel, and yeah, it just the motor just loves it so much more. It's so much great. And with the E85, because it evaporates really fast as well, is that the further back you go, the more time it's got to actually cool the charge before it goes into the motor. So that gives it more time to evaporate because it's such a longer distance, and the more fuel you're able to evaporate, if you ever put E85 in your hand or any sort of race fuel, that it goes cold. So the more time you give that fuel to do its thing and evaporate, the more chance you get a nice cold charge before it goes into the engine. So that's sort of what I looked at with this motor and what we tested on the dyno, and it proved itself really, really well. So the next thing was to basically make sure the air distribution was okay, which turned out that it wasn't with the modifications, like I said in the last video, that I had to do with that manifold to make it actually fit in my engine bay. So it actually wouldn't fit with the original design and the water sharing cooler setup that I had before. So we'll sort of scrap that for now, and we'll try to fix up the air distribution. So each cylinder now, basically, I'm not trying to tune an engine as one, I'm trying to tune each cylinder by themselves. So I want to try and make sure each cylinder gets the same amount of air at any sort of throttle position load, but it's just not going to happen with the openings on the throttle body, just because vice versa, one opening actually grabs and shapes the air, which is the bottom one here, and then the top throttle body on the top of the butterfly, the air actually doesn't get shaped, and it has a bit of a hard time getting through that opening. So the air actually prefers just to hit the back wall of the throttle and yeah, just go under that side of the throttle plate. So you've got to try and make sure that air distribution on the two down here are going to be even, and then I tried to make these two runners here as even as I can. That was the only flaw with this design, is the actual throttle body openings. You know, you're never going to get the same amount of airflow from the top to the bottom, because yeah, the throttle plate is the design of the throttle plate is just the issue itself. So yeah, so with the injectors, with this design, I went along and had a 30-degree bend. So basically the idea was to give myself some clearance, so I didn't have to actually put the big grooves out like in the other plenum down here. as you can see, got big grooves cut out which intrudes the port, gives you a bit of turbulence and whatnot. So I didn't want to do that, so the reason why the bend was to give us the clearance for the injector body. Next of all is we can get a lot better lining up with the actual center of the port, and also with the bend, this might help grab some of the spray from the top of the injector on the inside there. It sort of helps curve it around a little bit rather than just hitting like a flat wall and sort of rebounding off to the bottom again. Hopefully just with a little bit of a curve there, that the top spray will sort of hit it and then sort of run it like a berm, like a BMX sort of berm, and yeah, then get shot off, so hopefully it'll shoot up a little bit straighter rather than just straight back down. The other thing is with the bottom of the port here, my sort of theory is that the air would come through and it's wanting to travel in this direction, and then all of a sudden now it has to turn. So on the bottom of the port, the air's wanting to get shot straight up into the middle, and with the fuel spray you're going to have that coming down into the air path. So what I'm hoping is that the air would actually come down and actually help push the bottom of the fuel injector spray back up into the actual ports of the head, and try and keep as much of the actual spray atomized as I can. So that's sort of the reason why I've done these little bends on the actual manifold themselves, is actually just try and kick that bottom of the spray of the injector back up into the airstream, and hopefully I can get that sort of, hopefully with all that air pushing up on the injectors, that'll help keep the fuel more airborne by the time it hits to the back of the valve in the head. So that was the reason why. It's pretty much the same angle. It's probably a little bit more straighter than the other manifold, and they're actually a little bit further back. I've actually pushed the limits of what I can just because of the actual bend. I just sort of run out of room there and whatnot. But other than that, that's pretty much the quick theory rundown of the manifold. Got one vacuum line, just a little dash fitting in here. Just got it taped up for the flow bench test, but yeah, there's a little dash fitting there, and that's going to go to a vacuum manifold. It's just like an aluminium block which you can put all your vacuum line fittings into that, so then you only just have to have one vacuum line on the actual manifold itself. So when you take it on and put it on off the motor, yeah, it's only one fitting basically and one connection and a wire, so it's pretty simple. That's about it really. That's sort of a quick rundown. That's the finished design. Hopefully it works. We'll quickly do a quick flow test and we'll see some results. Okay guys, so we're ready to do the flow test now, and quickly just show you everything's pretty much how it was the last time in the video with the other manifold. All the same sort of setup really. So we'll just quickly zoom in. Now with these again, this is the area for each pipe. They're all the same, so at least you're going to show that that's the true reading. These little units actually measure the airspeed through the area, and then it calculates it, and then it displays the reading of the CFM. So that's how we're working it out. So each runner's got the same area calculated in each handpiece there. So we'll start him up and we'll have a look and see how things go. So as before, I'll just slowly close the throttle body and you guys can just watch the airflow on each runner, and yeah, just see the difference from the last manifold to the new one. So as we can see with the new one, we're almost getting 80 CFM across all four. Jumps around every now and again a little bit, but with the last manifold I was getting about 76 on this one, and I was about, I think it was 54 on number one cylinder. So yeah, basically we've just improved that a huge amount. Each cylinder now is getting the same amount of air, and this is basically the way that the air naturally wants to flow into the manifold. So we got this part right anyways. But as the throttle body closes, like we said before, that the top of the throttle body is going to have that restriction because just the angle of the plate prefers to shape the air to the bottom of the throttle body rather than evenly distributing the air. So that's the only flaw with this design of the manifold. But as we can see, it seems like it's going to work a lot better where it's going to be around 3/4 full throttle majority of the time, half the time. So that's a good thing. So slowly close them up and yeah, just keep an eye and see what the runners do. It's just slowly closing him now. So basically, as you can see, there is still a bit of an issue with the distribution with the air with the top of the throttle body, but hey, you know, that's how it goes, I guess. But other than that, really, we've improved air distribution a hell of a lot more, and definitely going to be interested next time when it's on the dyno at full throttle. So yeah, that's pretty much it. I'll throw the throttle body, I'll throw the manifold on, and get a few happy snaps of the manifold all bolted to the motor. Well, thanks for watching, guys, and hopefully we'll see you in the next video. I'm not sure if I'm going to do a video with the exhaust, or I might just do an update, so we'll see how we go, and cheers.
Get down to the B-side.